Okay, so I am fairly certain, I should have talked to Mr. Simpson or Mr. Sturts earlier today and I did not, but I am fairly certain you study direct variation and possibly inverse variation in Algebra 1. Okay, so I do think it is part of the curriculum because I think that you might even do some rational functions, which is what Chapter 7 is all about. But basically, in my own words, or like just in a descriptive way, not an equation just yet, direct variation means a constant is multiplied by a variable. Inverse variation is called inverse variation because essentially it is the inverse of direct variation. So think about inverse, opposites, undoing. If direct variation is a constant being multiplied by a variable, then inverse variation is a constant divided by a variable. Great.
Isn't it just called indirect variation?
It's called inverse. I didn't name them. It is possible, I suppose, in some textbooks that they would use the phrase indirect, but ours uses inverse. So I want you to be comfortable with that. Okay, now I'm going to put those things into equations. So what does that look like? I'm going to let my constant be the letter A. Okay, so A is going to represent my constant. Direct variation can look like y equals A times x, so it's the constant times a variable. And don't get too hung up on the letters x and y and where they go. We could also say that like x equals A times y is also direct because it's still a constant times a variable. Okay. Whereas inverse variation would look something like y equals A divided by x, or we could even say x equals A divided by y. And you can change those letters like in a word problem to represent different things, right? If you're talking about days, then you could use D for one of them. Okay. Now, I am going to put a little side note because I use this sometimes to check if things are varying inversely or directly, and it's to figure out how your constant might be formed. So, like, remember that in these equations, my A is my constant. What would happen if I solved for A? If I got A all by itself in this first equation, what would A look like? A equals y divided by x, or A equals x divided by y. Okay, so A equals, I'm just going to write one of them. If you notice, like if you have a table of values, if you have a graph with some ordered pairs, if you notice that all the y's divided by x's, or x's divided by y's, because it doesn't matter which way you do it, if they all equal the same thing, then it's varying directly. Which is kind of weird because it's like when you divide x and y, then it's varying directly, which means it's getting multiplied by a constant. Okay, and over here, your constant would be equal to x times y. So if you're looking for like, does this vary directly or inversely, and you divide all your x's and y's and they don't equal the same thing, then maybe check, do they multiply to be the same thing? Because if x and y keep multiplying to be the same thing, then it means that originally they varied inversely. And that would also, if you wanted to find your constant, that would also help you find your constant if you needed to. Okay, so I'll talk more about that when I use the red, okay, but it's just saying that the constant is equal to the product if it's varying inversely. The constant is equal to the quotient of x and y if it's varying directly. Okay, so we're going to tell whether these things are direct, inverse, or neither. And I've got 3 of them.
Ooh, maybe that's
What's that?
I said, ooh, maybe that. Can you tell just by looking at it, like if it's
Yeah, where's your constant in this one?
7
7. Is it being multiplied by a variable, divided by a variable, or neither?
multiplied?
Multiplied, so it's an example of direct. And that one's pretty straightforward because this looks like x equals a times y. So yeah, it's direct. This one, what's your constant? 3. Now it's a little bit harder to see if it's being multiplied or divided by a variable because all the variables are on the other side, but could you move a variable to the other side?
Yeah.
Yeah, what do you want to do?
Divide by x.
Divide by x, divide by x. So this is an example of inverse variation. So you might have to do like a little bit of algebraic manipulation if you're unsure if it's direct or inverse. And then the last one, x equals 7 minus y? Neither. I didn't give you any kind of rule for plus or minus. So we're not even really looking at like linear functions that have a slope and a y-intercept. We're never going to have a plus or minus in it. It's going to be so simple. It's going to be a constant multiplied by something, a constant divided by something. I'm going to give your pods. If you have 4 people, I'll give you 2 sets. You can just break up into partners. And I want you to make 3 piles. Direct, inverse, neither. I'll give you guys one instead of 3 of you. Same here. Direct, inverse, or neither. I'll give you a few minutes, then I'll show you my piles so we can see if you agree. Okay.
So pretty much the constant is on that number is always the number. The constant is always the number. That is, you multiply by x, so it'd be y equals 3 times x, which is direct. Oh, okay. Yeah, 2 times y. X, y.
Make 3 piles. Direct, inverse, neither. Okay, I'm going to show you my piles. I think it's probably easiest to start with the neither pile. That's at the bottom of my screen here. You should have 2 in the neithers. X equals y plus 4 and y minus 5 equals x. Okay. Inverse pile, you should have 4 cards. Y equals 5 divided by x. X equals 7 divided by y. And then the two that look like xy equals 8 and xy equals 5.4. Those are inverse. Everything else is direct. So there's quite a few direct. Probably the one that gets most often put in the wrong group is y equals x over 2. So like you want to say inverse because you see division with a variable and a number. The 2 is in the denominator, so what's really your constant?
2. Or x. Y.
X is your variable. What's your constant? What are you're multiplying it by 1/2 if you have x over 2. So this could really be written as y equals 1/2 x.
It can also be written as like 2y equals x, right?
Yep. Or you could move the 2 to the other side, so 2y equals x. And both of these are examples of direct. So yeah, it is important to note that in the inverse variation, your constant has to be in the numerator. It's the constant divided by a variable, not a variable divided by a constant. That really is direct variation. Okay. Anybody got any questions on those? Okay, can you make some up and put them back in the baggies? And just don't zip the baggie shut, just leave it open. That way I can squeeze the air out of it, and I'll come around and pick those up. Okay, moving right along. Some things that you should be able to do for your homework and also for your quiz this Friday is tell whether x and y show direct, inverse, or neither. And here you're given a table of values. So I'll give you some time just to kind of look at the numbers that are here and see if you can come up with a reasoning of whether it's direct, inverse, or neither. And then I'll talk about what I would do. Take some time to look at it.
So who's ABC?
Okay, if I am presented with a table of values, this is when I like to use that whole like A equals piece, which you got to remember when you do the A equals, it's kind of like the opposite of what you think. When variables vary inversely, their constant A is equal to the product of x and y. Right, because then y equals a over x. And if they vary directly, then a is equal to y divided by x, the quotient of x and y. You could do x divided by y instead of y divided by x. It doesn't matter. You either get the same thing or you don't. So I like to use it as like, is there a constant relating the quotient or the product of these x and y values? Did anybody find any connection between x and y?
Y equals -5x.
Okay, so you wrote the equation, y equals -5x. So yeah, there is some connection. -5 is it. I think most of you will just eyeball it, right? Now you got to be careful. We don't really want that it's going down by 5. We want to look at more as multiplication or division. But if I'm checking my y's versus my x's, 20 divided by -4 is -5. 15 divided by -3 is -5.
So is it y divided by x equals -5?
Yep. So 10 divided by -2 is -5. 5 divided by -1 is -5. So what Lexi said, y divided by x is -5. That means a is -5. So, I mean, all that this is asking really is if it is direct, inverse, or neither, when the quotient is always the same thing. That's an example of direct variation. If you were to check their products don't equal the same thing. -80, -45, -20, -5. So that's not an example of inverse variation. Okay, so any method you like, see if you can tell me whether this is direct, inverse, or neither. again, I'm going to do my quick and easy check, which is just like, do they have the same quotient or the same product? And it looks to me like they have the same product, right? 1 times 60 is 60. 2 times 30 is 60, so on and so on. So if x times y is 60, this is an example of inverse variation. Now, like Kaden did earlier, I mean, we can, once you decide that the constant is 60, you could write the equation, right? Y is equal to 60 divided by x. But this one is not really even asking for an equation. It just wants to know if it's direct, inverse, or neither. Now, if you check the quotients and you check the products and neither of them work out to always be the same number, then you say neither. Okay. And like I didn't check all of them by writing them down, but we could verify these last two also equal 60, right? 3 times 20 and 4 times 15. Okay, now let's get into the ones where we'll be asked to write the equation.
Is there going to be no calculator part on the formula?
No. The variables x and y vary directly. Use the given values to write an equation relating x and y, and then find y when x equals 5. X equals 12 and y equals 4. Really important on these problems is, are you reading the directions? It's going to tell you some really important information. What's the most important piece of information in this set of directions? That the two variables vary directly. So that immediately tells me I want to use the equation where a constant is being multiplied by a variable. So y equals a times x. What do you suppose you'll do next?
Can you plug in?
Substitution. Plug in your x, plug in your y. So we have y equals a times 12. Solve for a. 4 divided by 12, which simplifies to be 1/3. And so my equation could be y equals 1/3 x. So once you find the constant for one pair of x and y, if you're told that all x and y's vary directly, they all vary directly by the same constant for that problem. So then we know it's 1/3 for everything. And now can we find y when x equals 5? Yeah, just plug it in. Y equals 1/3 times 5, which is 5/3. Okay. Let's do another one. This time, the variables x and y vary inversely. We're going to use the given values to write an equation relating x and y, and then we're going to find y when x equals 3. X equals 7 and y equals -3. So change up of directions. Now we know they vary inversely. So that's when we have a constant divided by a variable, a over x. Solve the same way, right? Plug in your x and your y. -3 equals a over 7. It would be okay if you use the other version, like x equals a over y. You'll just have a different constant and your equation will look different, so you'll have to write it again as x equals. Let's see, a is equal to -21. So y equals -21 over 7. Or sorry, x for my equation. -21 over x. I have to write this equation where I could plug any x's that I want in, and then it says, and then find y. So you actually want to see this equation. Then find y when x is 3. So that would be -7. Done. Anybody got any questions for me so far? Okay, we'll do one that has fractions. So nothing changes just because there's a fraction. You just got to be able to work with a fraction, right? Right. Variables x and y vary inversely. Just that right there. Y equals a over x. Plug in your numbers. 5 equals a divided by 3/2. how do you solve for A? Multiply by 3 halves. Okay, so sometimes people, it's like multiply by the reciprocal is something we say a lot. But that's when you have something like 3 halves times A. Then you multiply by the reciprocal. If A is being divided by 3 halves, just multiply by that whole thing, 3 halves. And that will get you your answer. So if you're working with fractions here, A is 15 halves. I'm going to write up different ways that I'll accept your answer. You can write y equals 15 halves over x. You could write y equals 7.5 over x. Probably most of us would prefer that one. The only time I ask that you not use a decimal is if it's like divide by 1/3 or divide by 3. We don't want to round it. We want it exact, so we would leave it alone. And I'm also going to talk about this one right here because this we're going to talk about later in the chapter. It's called a complex fraction. The reason it's called complex is because there's a fraction inside of a fraction. So if you have 15 halves divided by x, that's like 15 halves times 1 over x, which then if you multiply can be written as y equals 15 over 2x. So what happens is the 15 stays in the numerator, the 2 drops down to the denominator with the x through algebra. But like most of us probably don't write all this stuff out. You just know that it comes out over here. These are all the same thing. Okay, we'll all get the same answer no matter what we do. Okay, this one said find x when y equals 3. So I'm going to say 3 equals, I'm going to use my last one, 15 over 2x. How will I solve for x? Multiply by 2x, right? Just like get it up. Think about like cross multiply. So this is 6x equals 15. And then divide by 6. So those are going to be what? 5 halves? A lot easier than guessing. Okay? Alright, one last thing. A word problem. So, when you're reading a word problem, you just need to pay attention. It's going to be basically the same thing, but they're going to apply meaning to it. So it says the time, T, in hours, that a group of roofers, that it takes a group of roofers to roof a house, it varies inversely with N, the number of roofers. So keywords there are varies inversely. I'm going to replace my y and my x with T and N. T varies inversely with N. So T equals A over N. And it takes a group of 4 9 hours to roof the house. So now you just plug those things in for N and T respectively. 9 hours equals A over 4, therefore A equals 36. So the time it takes roofers to roof the house is 36 divided by N. And, like, just stop and think about it. What do you expect to happen if you have more people working on roofing the house? It should take less time, right? Now, we could argue that maybe there's too many people at some point, okay? But we would argue that we would require less time. So there's probably, like, a good amount of people we want to have roofing the house. There's a follow-up question to this, which I'm not going to work out the whole thing. But then it just says, make a table showing the time it would take to roof a house with the number of workers. So then you would just plug these values in, right? T equals 36 divided by 2. T equals 36 divided by 6. T equals 36 divided by 9. T equals 36 divided by 12. And we're going to see the time decreasing. Okay. All right, your homework assignment is a worksheet. So Quinn is going to pass that out to you. Thank you, Quinn.
Who's getting picked on today?
Oh, did you have to pass out the gold sheet too? I'll try to pick on Charlie tomorrow.